Hello dear students, in this session let us continue with the next topic, that is Riemann-Stieltjes integration. Before moving to this topic, first we have to understand what is the difference between Riemann integral and Riemann-Stieltjes integral, right? So we have already seen Riemann integral. Now this is Riemann-Stieltjes integration. So there must be some difference between Riemann and Riemann-Stieltjes integral. So in Riemann integral, if I consider a function f of x, let us consider this is my function and the graph of this function looks in this way. Okay, so what was we were doing? If this is my interval a b, we were dividing our interval into number of sub-intervals. We were finding the lower Riemann sum and upper Riemann sum. If we add those two, we will get the actual function. This is how we were doing in Riemann integral. So this is f of a, this is f of b. Here I can write this as x1, x2, xi minus 1, xi. These all are number of partitions for this function. So the area under this function is nothing but your integral, that is Riemann integral. We can represent that as integral over a to b f of x dx. But in Riemann-Stieltjes integral, what happens is we will be having two functions. One is f of x, another one is g of x, or I can represent that as alpha x. This f of x will be always bounded function. This alpha x will be bounded, along with that it will be monotonically increasing function. Monotonically increasing function. So if I consider the graph of this, you can observe the main difference is here we have two functions, whereas in Riemann integral we were having only one function. So if I draw the graph, if this is some function, say f of x, I will be having one more function, say alpha x, which is monotonically increasing function. Okay, let us consider this is my interval. In general it is a to b. We will divide the interval into number of sub-intervals, right? So in this sub-interval, if you consider the baseline or reference line as your x-axis, and if you find the area under the curve of f of x, that will be your Riemann integral. But if you consider the baseline as your monotonically increasing function, say alpha x, and if you find the area under this curve, then that will be your Riemann-Stieltjes integral. Okay, that means I can represent that as integral over a to b f of x dx will be integral over a to b f of x d alpha of x. This alpha of x is nothing but your monotonically increasing function. In this Riemann-Stieltjes integral, if the value of alpha x, or if the function alpha x is x, then this will reduce to your Riemann integral. How? Because if alpha of x is equal to x, if I differentiate my alpha x, you will be getting d alpha of x is equal to 1 into dx. So substitute this in this function or in this integral, you will be getting integral over a to b f of x dx, which is nothing but your Riemann integral. So your Riemann-Stieltjes integral reduces to Riemann integral if alpha of x is equal to x. So the main difference between Riemann integral and Riemann-Stieltjes integral is, in your Riemann integral you will be considering the reference line as your x-axis, and you will be finding the area under this curve with respect to your x-axis, with respect to this baseline. Whereas in your Riemann-Stieltjes integral, the baseline will not be your x-axis, it will be your monotonically increasing function, and you will find the area under the curve between these two functions. That is nothing but your Riemann-Stieltjes integral. Okay, so now let us move to the next one, that is definition and existence of your Riemann-Stieltjes integral. So in order to define the Riemann-Stieltjes integral, RS is nothing but Riemann-Stieltjes. Okay, so first I have to consider a function f of x. This is a real and bounded function. Along with this, in the case of Riemann-Stieltjes, we will be having your alpha of x. Alpha of x is nothing but monotonically increasing function, and these two will be in the interval, that is closed interval a comma b. As usual, we were doing in the Riemann integral. First I will define my partition. Let us consider partition as P1 here. So this will be A is equal to x0, x1, so on up to xi minus 1, xi, so on up to xn, which is equal to b. This is my partition P1, right? So I can rewritten this as P1 is equal to a comma a plus h by n, a plus 2h by n, a plus I minus 1 h by n, a plus I h by n, so on up to a plus n h by n, which is nothing but b. Where what is this h? H is nothing but b minus a. Right? So now in this function again we will be having supremum and infimum with respect to the interval a comma b, as well as with the interval with respect to the interval xi minus 1 comma xi. So first I can say, since my function is bounded function, I can write f of x is in between your infimum and supremum. This is for all your x belongs to the closed interval a comma b. Right? Similarly, we will consider mi and capital Mi as infimum and supremum, and for the function f of x on the interval xi minus 1 comma xi, obviously this interval will be subset of your closed interval a comma b. So now I can write one more inequality, that is mi is less than or equal to f of x, and this is less than or equal to capital Mi for all x belongs to closed interval xi minus 1 comma xi. Alright, so now combining these two, I can get one inequality, that is m is less than or equal to mi. This will be less than or equal to my function f of x. This will be less than or equal to capital Mi, less than or equal to capital M. Call this as inequality 1. Now to this inequality I will multiply delta alpha I. Okay, so and since I have I value and I ranges from 1 to n, I will introduce summation along with this delta alpha I. So I will be getting summation m into delta alpha I is less than or equal to summation mi into delta alpha I. This will be less than or equal to summation mi delta alpha I, which will be less than or equal to summation m into delta alpha I. Right? So now I have to find out what is my delta alpha I. This delta alpha I is nothing but, this is a function and it belongs to the interval xi minus 1 comma xi, right? So delta alpha I can be rewritten as alpha of xi minus alpha of xi minus 1. Don't get confused because here it is a function. In the previous session, in the previous concept, that is in Riemann integral, we were multiplying delta xi, and there this xi was coming from the interval, so you were writing xi minus 1 xi minus xi minus 1. Here alpha is your function, so you will be writing in this form. Okay, so now what is summation delta alpha I? This is nothing but summation I is equal to 1 to n alpha of xi minus alpha of xi minus 1. If you find out the value of this by expanding your summation, you will be getting alpha of x1 minus alpha of x0 plus alpha of x2 minus alpha of x1 plus so on, and it will end like alpha of xn minus 1 minus alpha of xn minus 2 plus alpha of xn minus alpha of xn minus 1. So these terms gets cancelled. At last you will be getting alpha of xn minus alpha of x0. From the partition, what is xn? It is b. What is x0? It is a. So summation delta alpha I will be equal to alpha of b minus alpha of a. Right? So now in the inequality summation mi delta alpha I, this will be L of p comma f comma alpha, and we pronounce this as lower Riemann Stieltjes sum. Similarly, summation mi delta alpha I will be u of p comma f comma alpha, and this can be pronounced as upper Riemann Stieltjes sum. Right? So now this is if I consider partition as P1. Similarly, if we have more partitions, you will be getting L2 comma U2 and L3 comma U3, that is with respect to partition 2 your lower Riemann Stieltjes sum, this is upper Riemann Stieltjes sum with respect to partition 2, and this is for partition 3. It will continue so on, right? So I can rewrite this as L2 comma U2, L3 comma U3 and so on be the lower and upper Riemann Stieltjes sum with respect to partition P2, P3 and so on. You can write in this way. So now as you did in the Riemann integral, what will happen for L of p comma f comma alpha? This is nothing but maximum of L1, L2 so on. Similarly, your u of p comma f comma alpha will be minimum of u1, u2 so on. Right? So now your lower Riemann Stieltjes integral can be represented as I lower bar of f is equal to lower limit integral over a, this is lower limit, to b f of x d of alpha of x. We can write this as limit n tends to infinity L of p comma f comma alpha. Okay. Similarly, the upper Riemann integral will be I integral a to b upper bar f of x d of alpha of x, which is equal to limit n tends to infinity u of p comma f comma alpha. So in the previous session, that is in Riemann integral, if upper and lower Riemann sum or equal, then we were telling that the given function is Riemann integrable, right? Similarly, in this case also, if upper Riemann integral is equal to lower Riemann integral, then this is nothing but the function is Riemann-Stieltjes integral, and you will represent that as R of alpha of x on closed interval a comma b. That means your function is Riemann-Stieltjes integrable function with respect to the function alpha of x on closed interval a comma b. Okay. So this is how the definition and existence of Riemann-Stieltjes integration can be explained. Now let's solve one problem on this topic. This is the first problem. The function f of x is equal to x square and the monotonically increasing function alpha of x is also x square. We have to prove that this function is Riemann-Stieltjes integral function with respect to x square on closed interval 0, 1. That means we should get lower Riemann-Stieltjes integral and upper Riemann-Stieltjes integral as equal. Okay, so the first step will be we are considering our closed interval 0, 1, and you can find the value of h by taking b minus a, so it will be 1. Now let us do the partition. So p is equal to 0, 1 by n, 2 by n, so on up to I minus 1 by n, I by n, so on up to 1. This is nothing but b, this is nothing but a. So this is your partition. Now find the value of mi. Mi is nothing but f of x I minus 1, that is f of I minus 1 by n. So it will be I minus 1, we have x square here. So I minus 1 by n the whole square. So it will be I square plus 1 minus 2i by n square. Right. So similarly find out capital Mi. Capital Mi is nothing but f of xi. It will be I square by n square. So now we got the value of Mi, capital Mi and small mi. Now let us find the value of delta alpha I. So you should be very careful here because alpha value is x square. Now what is delta alpha I? Delta alpha is nothing but alpha of xi minus alpha of xi minus 1. Substitute the values here. Alpha of xi means we have alpha of x is equal to x square. So alpha of xi is nothing but xi whole square. What is xi whole square? It is I square by n square. Similarly find out alpha of xi minus 1. So you will be getting I square by n square minus I square plus 1 minus 2i by n square. If you simplify this, you will be getting 2i minus 1 divided by n square. This is my delta alpha I. Right. So now L of p comma f comma alpha, we have to find this. So this will be summation mi delta alpha I. Substitute the values here. You will be getting what is mi? It is I square plus 1 minus 2i by n square into delta alpha I is nothing but 2i minus 1 by n square. Solve this, you will be getting 1 over n power 4 into summation I square plus 1 minus 2i into 2i minus 1. This is nothing but 1 over n power 4 into summation. If you multiply these two things, you will be getting 2i cube plus 2i minus I square minus 1 plus 2i. Right? And this is minus 4i square. So you will be getting 1 over n power 4 into summation 2i cube plus 4i minus 5i square This 2 gives you 5i square minus 1. So this will be 1 over n power 4 into 2 into summation I cube plus 4 into summation I minus 5 into summation I square minus summation 1. You already know the values of summation I cube, summation I square and summation 1. We have seen this in the previous session also. So just substitute all the values and simplify this. So you will be getting 1 over n power 4 into this is 2 into n square into n plus 1 the whole square by 4 minus 5 into n into n plus 1 into 2n plus 1 divided by 6 plus 4n into n plus 1 by 2 minus n. Right? So now this will be nothing but we have to simplify this. So if you simplify this, you will be getting this is equal to 1 over n power 4. Here I will take n power 4 as common. So it will be 1 plus 1 by n the whole square divided by 2 minus 5 n cube 1 plus 1 by n into 2 plus 1 by n divided by 6 plus 4n square into 1 plus 1 by n divided by 2 minus n. After simplifying that, you will be getting 1 plus 1 by n the whole square divided by 2 plus 2 into 1 plus 1 by n divided by n square minus 5 into 1 plus 1 by n into 2 plus 1 by n divided by 6n minus 1 over n cube. Okay, this is nothing but your L of p comma f comma alpha. Now I have to find out the lower Riemann integral. So this is integral over a to b f of x d of alpha of x, right? This is nothing but limit n tends to infinity L of p comma f comma alpha. So this will be equal to limit n tends to infinity. Substitute these values here. It is 1 plus 1 by n the whole square by 2 plus 2 into 1 plus 1 by n divided by n square minus 5 into 1 plus 1 by n into 2 plus 1 by n divided by 6n minus 1 over n cube. So if you substitute the limiting value, at last you will be getting the value 1 over 2. This is your lower Riemann-Stieltjes integral. In the similar way, find out u of p comma f comma alpha, that is nothing but summation mi into delta alpha I. So this is summation I by n the whole square into 2i minus 1 by n square. So I will be getting 1 over n power 4 into summation 2i cube minus I square. You can split this as 1 over n power 4 2 into summation I cube minus summation I square. Substitute these two values and simplify. You will be getting 1 over n power 4 into n power 4 into 1 plus 1 by n the whole square by 2 minus n power 4 into 1 plus 1 by n into 2 plus 1 by n divided by 6n. Again, if you simplify this, you will be getting 1 plus 1 by n the whole square by 2 minus 1 plus 1 by n into 2 plus 1 by n divided by 6n. So I upper limit of f is equal to integral over a to b f of x d of alpha of x. It is nothing but limit n tends to infinity u of p comma f comma alpha. So limit n tends to infinity, substitute this value. It is 1 plus 1 by n the whole square by 2 minus 1 plus 1 by n into 2 plus 1 by n divided by 6n. It is, after substituting the limiting value, you will be getting 1 over 2, because since you have n here, this whole term will be 0, this term is 0, so 1 by 2 it is. Now we can say that I upper bar of f is equal to I lower bar of f. This implies function f of x is Riemann-Stieltjes integrable function with respect to the function x square on closed interval 0 comma 1, or you can write that f of x is a Riemann-Stieltjes function, then r of x square on closed interval 0 comma 1. So this is how the problem is also different from a Riemann integral. The main thing is, in Riemann integral you are having only one function, that is f of x, but when it comes to Riemann-Stieltjes integral functions, you will be having two functions. One is just f of x and another function is alpha of x. You will find the integral functions with respect to alpha. So you will define delta alpha I. Delta alpha is nothing but alpha of xi minus alpha of xi minus 1. You should be very careful while finding the value of delta alpha I, because it is with respect to the function which is monotonically increasing, right? So now I will give one problem as assignment. Try that problem. We will discuss that in the next session. F of x is x square itself, and this belongs to Riemann-Stieltjes of x cube on closed interval 0 comma 1. Everything will be same, but you will be getting a different delta alpha I value. This is delta alpha I is equal to alpha of xi minus alpha of xi minus 1. So it will be xi cube minus xi minus 1 cube. Since the interval is also same, it will be I by n the whole cube minus I minus 1 by n the whole cube, right? Here this is just I cube by n cube. Here it is 1 by n cube into I minus 1 the whole cube. Here substitute the value, substitute the formula a minus b whole cube and simplify this. You will get your delta alpha I value. Okay, so try to solve this problem. If you face any difficulty, I will be there to help you out. Thank you.